Okay, Srija. Do you need, yeah. Thanks. All right, you guys. This week, let's see, today you've got homework 4 coming in, and I'll briefly answer any questions that you might have of general interest. If you have specific questions about something that you're working on, ask me after our class. I'll be available from after class up until about 2:30 when I have to teach data structures. I put sample exam questions here in the supplemental column. This is not really meant to be indicative of the length, but only of the type of questions that you might run into. Chances are it'll be slightly longer than this, but still designed for you to finish in a 50-minute class period, not the full hour-and-a-half class period that is allotted to us. Remember that I asked you to look at the self-test questions, all that sort of stuff. There may literally be stuff that we've never talked about in class that's part of the readings that could be fair game on an exam. So how do you prepare for this? I think one thing that you should do between now and Wednesday is to at least review all of the self-test questions, and then Wednesday come in and ask me questions, because Wednesday is a review day for the first exam. And I will spend maybe 20 minutes or so answering questions that you might have on Wednesday, and then we're going to spend probably the second half of the class just working together on a few questions that I'll give you on a worksheet. Today we have a presentation by Srija. Wednesday we have Brett. I will talk a little bit about why functions. Why do we care about having functions? Some of the broad stroke subjects of sections 4.4 and 4.5 in the book. And then in an application of those kinds of ideas, I will briefly talk about the Fahrenheit to Celsius conversion program that we wrote way back in the first week of class. And then I will do, we'll sketch out exercise 4.7 from the book right here. It's just a simple, it's very similar to the Fahrenheit to Celsius conversion program. But I feel like you can't see enough of this kind of planning and execution before you actually have to go and do it yourself. It's good to see lots of examples. And that said, I also encourage you, if you're having trouble with syntax or just basic concepts, don't forget that I have these, all of these example programs that I do in class are here by date and with fairly descriptive names. So for example, if you're trying to figure out how a function works, this is a good thing to look at, where we have the declaration up here and the definition down here and then the usage in the main program. If you're ever stuck on syntax, you should browse these programs. And as you prepare for Friday's exam, you should browse these programs and make sure that you understand what happens in every one of these programs. Why does every line make sense? Questions about anything? Go ahead.
You said we only have 50 minutes? Or
50 minutes. If you want to stay longer, I'm somewhat amenable to that. I do have to teach at 2:30, but the test itself will be designed to be completed in at most 50 minutes. It's much closer to sort of a quiz kind of thing, just to make sure that you have been doing the readings and you've been writing the programs. Other questions? Rachel?
So one of the requirements that you put for the bisection program was to follow the style guidelines and section something.
Oh, that might have been, well, go ahead.
And a lot of the things that it tells you to do style-wise are not the way that we've seen you doing it in class.
Is there something in specific? Because I think that might have been slightly too strong of a statement. So let me pull that up and show everyone what I'm talking about.
I think the main one I noticed was you just spread everything out a lot more. So like every little thing got its own line.
Yeah, you know, if you've been doing okay with the indenting and the neatness points on previous exercises, you're fine. Don't worry too much about that. Okay?
You don't need to follow.
Not to the letter. Okay. Other questions? Emily?
So if you say on like the exam, like write a program to do this, are you looking for like the program from like include all the way down to like the last bracket, or just kind of like the meat you would?
I typically will, in fact, almost certainly will not ask for a complete program. The word that I use often is the word snippet.
Okay.
And by snippet, what I mean is something that makes sense in context, but you're not even having to declare stuff unless I explicitly ask you to write a variable declaration. So, you know, write a snippet of code that prints the numbers 1 through 9 to the screen. Okay? You don't have to declare I. Just write me a for loop or a while loop that does it. And that makes sense in that view. That's a good question. Yes, Lauren. Yes.
Is there a way to use a variable in the main function, like in main, and also use it as one of the arguments for one of the functions, or for the function, the bisection function that we've declared?
No question. You're doing that with the tolerance variable, actually.
Yeah.
So you get the tolerance variable in main,
I was just having trouble.
and then you pass it into.
Yeah, because like when I tried to declare or to define the function below, it was like having trouble with like.
It sounds like there might be some other syntactical issue that I'd be happy to look at afterwards. But back to Lauren's larger question, you've got the bisection function, which takes XL, XR, and tolerance, right? Those three variables. When you use it in the main program, you can declare. In fact, you need to have XL, XR, and tolerance actually already declared, because you're going to ask for those values from the user before you actually use the bisection function, right? So you're going to get those three numbers, and then you're going to plug them into the bisection function, and that should work. So there's probably some kind of other syntactical roadblock. Other questions?
So it's almost like you're having to declare them twice.
Sort of, yeah, because you've got the actual variables in the main program, XL, XR, and tolerance, and then you have the dummy variables down in the function definition, which are necessary in order to build the definition of the function. So in a sense, yeah, you've got to kind of declare them twice, but the ones down below are never actually real variables. They're just kind of placeholders for the 3 real variables that are coming in from the main program. Other questions? Good questions. All right. So the book talks about the notion of procedural abstraction and uses this to justify, it's one of the reasons to justify using functions. Why do we have to write a function when we can just as well, in the main program, write the instructions for the bisection method and be perfectly happy never having used a function at all? Can people talk about why we might want to write functions rather than put code just in the main program? Madeline.
If you want to use it in multiple times in different. Absolutely.
So for reuse, that's probably the biggest justification for writing a function. If it's going to be used in lots of different places in your main program with lots of different values, write it once and call it many times. That's the most concrete reason. What are some of the more esoteric reasons possibly that the book talks about or that you can think of?
I mean, it looks nicer. That's
I
kind
think,
of a great reason.
yeah, so aesthetics,
Yeah.
in a sense. Readability is another way of doing it. Let's recall to mind the Fahrenheit to Celsius conversion program. What was its purpose? It was to take degrees Fahrenheit, convert them to degrees Celsius. What was the process that you went through in order to do that? You got the degrees Fahrenheit from the user, you converted it to degrees Celsius, and then you printed out that result. Conceptually, there are 3 big tasks there. Get the degrees Fahrenheit, compute the degrees Celsius, report the degrees Celsius. And you could have a main program that literally said just those 3 things. Get Fahrenheit, compute Celsius, report Celsius. You could have 3 functions that said that. And what you have is a very readable program, aesthetically a much nicer program perhaps than just having all the gobbledygook in main. So that's a real reason. Aesthetics. Why are aesthetics important in a program? There are actual practical reasons for having aesthetically pleasing programs. Go ahead.
Well, if while you're writing it you have errors, it might be a lot easier to find them.
That's absolutely right. So if you have a neat, well-constructed, well-compartmentalized program and you have errors, they're easier to find. And that is the practical reason for aesthetics. That's the practical reason for indenting. So that you know all of the statements indented at this level belong to these curly braces. All of them indented at this level belong to these curly braces. It just makes it easier to look at and debug. Okay, what else about procedural abstraction and using functions? There's one more kind of related issue to aesthetics. But
Isn't it
anything.
easier for other people to use them?
It is. So for sharing code, writing a function is really ideal. Because I can write a program, I can write a function, I can describe what its arguments are and what its output is, and then I can literally share it with anyone that I like, and all I have to do is tell them how to use it. Much more difficult to, say, take your bisection program where you haven't used functions and somebody else wants to run the bisection method and you hand them the program, and then what do they have to do? They have to read your whole program and try to figure out what part of the program is actually doing the bisection method, pull that out and put it into their own program and then use it. But if you've written a carefully constructed, encapsulated, compartmentalized function, that doesn't have any kind of externalities related to it, things that, external things that it relies on, and you've got instructions, you can just hand them the bisection function. And frankly, our bisection function is a bit wanting in that particular area. How is our bisection function wanting in that area? Why would it be hard for us to share our bisection function with someone else? What would be a possible stumbling block to someone using that function the way it's written right now? Yeah, go ahead.
Well, they can't put in their own equation. Like we have, unless they have like our actual written code, then they would have to change the equation in their code.
So our function relies on the pre-existence of some function f, right? Remember that? And what if the user already has a function f that they don't want to do the bisection method on? They have some function f that they're doing other things with. Well, by hard coding that f into our bisection function, we've kind of tied the programmer's hands. If you have an f, too bad. You've got to rename it because we're using that f in our bisection function. The reason that I didn't have you write a slightly more general version of the bisection method is because I didn't want to talk about the notion of passing a function into another function. But you are allowed to do that. I am allowed to make one of the arguments to the bisection method a function. And I just didn't want to go there this early in the semester. Okay. Another really nice thing about functions, I want to finish this discussion, so I'm going to give it away, is organization. Taking a large task and breaking it up into small, manageable pieces. For example, let's go back to Fahrenheit to Celsius. Again, this is such a toy example, it's hard to really, in fact, let's talk about bisection instead. Bisection depends on three values, right? It depends on XL, XR, and tolerance. Now, I've asked for other things from you for this program. I've asked you to offer default values. Gosh, I don't know what else I've asked. Some kind of above and beyond, for example. But if you are writing a function, you can just have a main program that all it does is call that function with given values, x left, x right, and tolerance. And you can really focus in and make that thing work by testing it on known functions and known intervals with known solutions. And once you get that thing working properly, once it's meeting these specifications that get listed here in this comment box, you don't ever have to look at it again. Then you can just work on the other aspects of the program, knowing full well that when you're ready to use bisection, it's ready to go, it's going to do the right thing, and you never have to worry about it again. When you're working on a large software project, for example, there's probably a whole building of people in Redmond that work on Microsoft Word. Everything they do is functions, because you've got this department over here that's responsible for who knows what, right? Opening up spreadsheets, for example, and then you've got this department over here that's responsible for doing, PowerPoint animations or something ridiculous like that. Everything is planned from the top down, and by the time it gets down to a particular programmer's desk, that guy is writing, the twisty, twirly text function for PowerPoint. And all that guy has to do is meet the specifications that his managers put before him, that the inputs are this, the outputs are this. The guy writes the function. Nobody cares how he did it. He turns it back into the manager, and the manager's happy and moves on and never looks at that piece of code again. That's an idealized situation, but that's in principle what's going on. We can take large software projects and break them down into little atoms that are easy for individuals to program, and then we can glue them all back together in a main program. Questions about that? Okay, Srija. this thing, right? Did you open it already? No. Okay. And I'll let you figure it out.
Okay, this is my topic, and well, we all know what a drone is, but that's the common name of a drone. The official name is Unmanned Combat Air Vehicle, and what that means is that it's a vehicle more like an aircraft, but without the human pilot controlling it. So it has more weapons and no human. So it has all the human component, like all the equipments that the human pilot would need, such as the cockpit, the ejection seat, the flight controls, the pressure and the oxygen control. They are all removed, and this gives it more space to load more weapons and less weight and increased range and things like that. That's why it's really popular for combat, because with no pilots in charge on the vehicle, the loss of human life is minimum, and you can just control better. You can send in more drones to conflict-prone area, and you can deal with conflict better. So the way an unmanned air control system works is that it has a few components. It has an unmanned air vehicle, which is the drone. It has a control system, which is any land or sea-based control system that has the human controllers, like the pilots and the sensor controlling the drone, and it has a control link, which is transmitting the communication from the sea and the land-based control system to the drone, and it has other related equipment based on whether it's being used for say aerial bombing or for just surveillance. So the two main drones used by CIA in USA are General Atomics MQ-1 Predator. It's basically used for surveillance. It's a medium altitude, long endurance unmanned vehicle, and it has been in operation since 1995, and it's basically goes to unfriendly territories and collect informations using cameras and sensors. But it has been modified a couple of times, and now it can also accommodate 2 Hellfire missiles, and it can launch them too. It can be controlled by any satellite anywhere in the world if it has the necessary system controls. The second one, and the more recent one, is the General Atomics MQ-9 Reaper. It is a much better version of the Predator, and the difference between the Predator and the Reaper is that this one is a high altitude surveillance vehicle, and it can also drop bombs. So in addition to collecting information about other regions or wherever it's positioned to go, it can also take part in actual combat. It is much larger, much heavier, and it has a whole lot, like it's more, in a way, deadlier. It's deadly, so because it has greater power. It has a 868 kilowatts compared to the 712 of Predator. It has a range of 6,000 kilometers compared to the 100-kilometer range of the Predator, and its maximum speed is 260 knots compared to 117 knots of the Predator, which is pretty cool. Makes it really profitable from the military's point of view. They are increasing it in an increasing, like they're using it in a much increased number these days. Well, that's from the military point of view. From the point of view of the people who are affected by it, these are the statistics of the drone strikes. So as you can see, there's a significant number of civilians that are reported dead, and not all the people died were militants, which is what the military claims to do. So according to the laws of wars, you have to limit the death of civilians and try to identify the target as accurately as possible. But that's a problem in case of drones, because it's based on camera images and your radar footage, so you cannot be sure that if the person you're targeting is accused militant or not. And it also has a problem of accountability. You can't really say who's responsible for it, because the administration, at least the US administration, in case of that, it's moving more and more towards the civilian operated drones from the military operated drones. So, well, that's another problem, because these people who are civilians, they are not recognized as the proper people to be engaged in combat, because they do not understand and accept their role in conflict, so they can be prosecuted and possibly sent to prison. But it's still being used and by civilians. And yeah, the one reason drones are used a lot is that because it's specific, which from the statistic we can see it's not very specific. For example, like the Taliban chief that was supposed to be killed in Feb 2010, Baitullah Masood, there were 16 drone strikes, and out of that, only 2 were on location where he was supposed to be there, and 280 to 410 people died, and they were mostly civilians. Only 75 of them were suspected militants. Well, and that, in addition to the civilians being killed, there's also a growing concern that if you remove the soldiers from the wars, there's an increased risk of them treating war as just more like a video game thing, and human lives just become the dots on the screen, and it's not that effective. Like, it's kind of an unfair ground for the people who are being attacked and compared to the people who are attacking them, because they do not realize them, like, what they are doing in most of the cases. And those people, when they do realize, or they see the magnitude of their actions, most of them suffer from post-traumatic stress disorder, which is prevalent among a lot of drone controllers. Well, drones are in use in a lot of countries, like in Yemen, in Iraq, Afghanistan, Pakistan, and even though the U.S. government claims that it is for, like, it's for their own good, actually, what I researched and what it showed me is that it's actually making the Al Qaeda to recruit members, like, more easily, because it's easier to recruit people who have lost their family members to drone attacks when they were not even involved with the militants. And that is kind of creating a safe haven for all these terrorist camps in these countries, which is what the drone attacks is supposed to eliminate. It's also affecting the relationship between the US and the countries that they're attacking, because it's a very short-range plan, because if you keep on killing people, they are the people who have families around you, and they will eventually protest against the government, and the government would lose power, and then the relationship between those countries is ruined. Well, those are the ethical problems associated with drones. Do you have any questions?
Time for one, maybe.
Okay. Sure.
How big are they?
How big are they?
Yeah.
Well, the Reaper is, I think the wingspan is, I don't know, it was something like 100. I
See
think.
that thing on the rear? That's a sort of a standard size propeller. It's like the size of the propeller on the airplane up at the Walla Airport, for example. Kind of gives you a scale. Like that the intake vent on the top, between the top tail fins and the propeller, that's essentially a turboprop engine, and it's probably about the same size as the engine on the Horizon plane up there.
Are there other countries that use them?
Actually, there are a lot of countries that are using it. Most of them, I think Britain has a plan for a new increased, a much better version of the drone. They are improving on the Reaper, which will also include, in addition to missiles, it can also accommodate laser-guided bombs things. So there's China using it, there's Iraq, there's Iran, India has a couple of them too. So it's not only US using them, it's pretty much prevalent all over the world.
We could go on for hours on this one, but thank you, Surya.
why do I talk about this in a programming class? How many of you guys have flown model airplanes? Any of you? Okay, that's a much harder thing to do than flying one of these. These things fly themselves. You just tell them where to go, and they go there. That's all programming, right? So the piloting systems on these things are all software. And the reason I like to talk about this subject in this class, I've done it for a couple of years, is there will come a time when policymakers will try to cut the human out of this whole equation. And they'll just be flying around on their own and making kill decisions on their own. And that's what I want you guys to take away from this, is this stuff needs to be dealt with now before the slippery slope gets us to the point where there are things flying around in the sky that can kill people at will with no human in the loop at all. All right, back to happier things. Well, happier for me anyway. So what I'd like to do for the remainder here is sketch out the solution to problem 7 here in the book. This is problem 7 at the end of chapter 4. Very straightforward kind of programming project where you're writing a program to compute the gravitational force F between two objects of mass m1 and m2 separated by a distance d. What I would like to do is plan and perhaps write a couple of functions to execute this exercise. And to start out with, so go ahead and read this thing. So we're going to write a function definition that takes arguments for the 3 values. Use a globally defined constant for g. Embed your function in a complete program that computes gravitational force between 2 objects given suitable inputs. Similar to the process that, go ahead, Rachel.
What's the 3 that keeps them after the 6.673 and after the
It's probably is that in the book? It must be in the book because this is a photocopy. My guess is it's supposed to be an X and it's a typo. So 6.673 times 10 to the minus 8. Physicists in the room, does that sound right? Yeah? Okay. And then the units are grams times seconds squared. Yeah. I didn't even notice that, but yeah, that's clearly a multiplication symbol gone wrong. So similar to the process that I described earlier, what I would like to do is write a main program for this that is comprised almost entirely of functions. So what are the functions that we need to carry out this calculation? What would be a good division of labor for these functions so that functions are doing sort of similar kinds of tasks? Dylan, did you have a...
Well, yeah, I sort of had like different functions that you use in this case.
So, yeah, let's go ahead.
I mean, you could look at it as like 3 functions, I guess. It's like input your ends, and then compute it using like the formula for force, and then output that computation. But you probably don't need more stuff.
So these are the 3 main tasks that you kind of envision here. Okay, I agree. Let's talk about what we should call these 3 tasks in terms of function names. So what's a good name for getting the inputs? Get inputs? Yeah, so we'll just keep that, get inputs. Gravitational force is probably good enough. Output, maybe report force or something like that. or just report, it hardly matters. But you do want to give somewhat descriptive function names. And what'll happen in the main program is something fairly similar to this. Get inputs. And we'll leave the arguments out for a second. Compute the gravitational force. And then report. And I'm not saying that this is exactly what the main program will look like, but in principle, this is what it would look like. A function that gets the inputs, a function that computes the gravitational force, and then a function that reports the data. All right. Boy, I don't know, which one should we do first? Let's do gravitational force first, since that's kind of the most straightforward one. And here is sort of a demonstration of the real advantage of writing programs from a function perspective or from a procedural perspective. So let's talk about, what did I call this thing? Gravitational force. Let's talk about the middle one. How many arguments and what type? 3, and there'll be doubles. Specifically, using the variable names here, what are the 3? M1, M2, and D, exactly.
You can also have G, just because gravitational force depends on the planet you're on.
Well, G is the gravitational constant, which actually doesn't depend on.
Doesn't?
The capital G thing doesn't depend.
Oh, yeah. That's it.
Yeah. So 3 doubles. And we can call them, we'll just use the dummy variable names even though they're not necessary here. But again, sometimes including dummy variable names helps the user of your function know what each variable is for. And what should the return type be? I think somebody said it, but say it again. Double. Why not an int? Because it's going to have some decimal values. You know, there's going to be some decimals to the right of the decimal point. So it would be an int. It certainly wouldn't be a character or a string or something like that because it's a number. But what kind of number is it? It's going to be a double or a float if you're not interested in high precision. Typically, you'll give a comment. For example, this computes the gravitational force what else would be an important thing to mention here for the user of your function? Yes, absolutely. So at some point you should mention units. A typical way to do that would be something like just put G here and say G here. And D, I assume they're using meters, but maybe not. Maybe they're using kilometers. Centimeters, yes. That's not my most favorite unit for gravitation, but whatever. So that would be a nice, fairly useful comment if you were worried that a less sophisticated user might be using this. Maybe you could go full on and say grams here and grams there, but we'll just leave it at G and CM. The nice thing about putting the dummy variables up here at declaration, even though they're not necessary at this point, is it gives you something to talk about in your comment. M1, M2, D, and it also tells the user where to put these various values, what the order is. So the first slot is M1, the second slot is M2, and the third slot is the distance D. Computes the gravitational force between two objects of mass, yada, yada, yada. Okay. Let's go down below and actually define what this function does. I usually just copy and paste and then replace the semicolon with a pair of curly braces, and then I start writing the inside. All right, let's look at the formula here. What's the body of this function going to look like?
Well, you're going to ask for the inputs, right?
I'm going to ask for them in another function.
Given those inputs, multiply them together and divide by them.
So it's going to simply return G times M1, what is it, M1, M2 over D. M1 star M2 slash D slash D. So it's going to do that. A pretty simple function. And it's going to yell at me if I try to compile it right now. What's it going to yell at me about? I didn't declare G. So if I do that, G was not declared in this scope. This is going to lead me to, I haven't talked about this in class, but certainly it's been in the readings. You should use a globally defined constant for the universal gravitational constant. Let me show you the syntax for that. And this is a fairly common C++ technique. .673 E -8. So I can, at the top, define capital G to be that value, 6.673 E minus 10. That is how we do scientific notation in C++. And if I compile it now, what will happen is the preprocessor will come through and it'll see that G and it'll replace it with this string of characters, which actually means something, and then it'll compile. And so this is different from declaring.
What's the difference?
I'll tell you in a second. I'm trying to figure this out. 20. G star. I bet I have to put parentheses around this. No? I don't know what it's yelling at me about here. I'm actually relieved that I don't have to put parentheses around that. M1, M2. Let me see this error again. Invalid type of unary star. Anybody got a clue? Not for multiplication. Alright, well, let's try this. And this. It's happy with that. Might not like my, It's okay with that. I bet it's not going to like this. Oh, that's okay. How about this? Weird. It just doesn't like it there for some reason.
Should I put it after the terms?
That's what I'm going to do. I'm not sure why it doesn't like that. Okay. Anyway. All right. So aside from that slight weirdness, this ought to compute the gravitational force. Now, it's at this point, and this is another point that I want to emphasize that's really nice about functions, is it lets you build a complicated program in baby steps, a little step by step by step. So I've got this function written. It probably would be a good idea to test it and make sure it's behaving properly. So why don't I go up here and, I don't know if they actually give us, it doesn't really matter if they give us examples. What we should do is test this on an example that we know the answer to. So give me a set of parameters for which I know what the output should be. All ones, absolutely. If I stick in 1, 1, 1, I should get out what? I should get out G. So let's test that. And I do. Yeah, sure, if I stick in a 0, I should get 0. And, you know, you could test this thing as much as you want. This is such a simple function, I'm fairly confident that it's working at the moment. But for a more complicated function, like, for example, the bisection method, you might want to test it on several kinds of known inputs that maybe test weird extremes or something like that. So I've written this thing, I've tested it, I can forget about it. Let's write the getData function. Let's just call it get inputs or get data. Yeah, get inputs. This is a really weird. This gets us into chapter 5 a little bit. Let me show you something. Double M1, double M2, and double distance D. So I'm getting inputs from the user M1, M2, and D. I don't really want this thing to return a value, and if that's the case, I use the special keyword void, which indicates that it doesn't return a value. And here, probably to write a better comment, I should say returns the gravitational force between two objects. And here, we'll just mention that it returns nothing. Okay, let's talk about what the guts of get inputs should look like. So I'm going to copy this line, I'm going to go down below and paste it, and replace the semicolon with a pair of curly braces. And let's talk about how get inputs should work. So it needs to get 3 pieces of information. What's going to happen in here? What's the first thing that you want to do? Yeah, prompt. And get that value. And let's do mass 2. And let's get the distance. Probably should put units in here just to be really user-friendly. And because this function doesn't return anything, I don't need a return statement at the end. So So I'll just leave it at that. And when I call this thing, it will it'll do these three things. In fact, yeah, well, let's just leave it at that. So let's go up here. Now that we've written the function, let's test it. And let's go and call it. And let's run it. So mass 1 we'll say is 1, mass 2 is 2, and the distance will be 3. Nothing really happened there. How do I figure out if it's doing the right thing? So I could see out M1, M2, and D, right? So what's this thing going to look like? It's going to go... It's immediately going to go and take those inputs and shove them into gravitational force, right? Like that. So what I should do is just test between here and see if M1 is what we want, M2 is what we want, and D is what we want. Okay, so if I do that, I get junk in there. It says M1 was 0, M2 was 2 times 10 to the negative 317, and M3 was 6 times 10 to the negative 310. Okay, this brings us to the topic. We'll talk about this more after the exam, but it's certainly not something that you can't learn right now. When I pass things into a function like this, the function doesn't get to work on the original variables. Instead, what it does is it works on copies of those variables. So, for example, when I come in here, it gets a copy of M1, a copy of M2, and a copy of D. It plugs them into this formula and returns the value F, and that'll get stored here. Get inputs is, at some level, fundamentally different from gravitational force, because get inputs is trying to assign values to M1, M2, and D. And what we're running into is the fact that functions only get to work on copies of those variables, not the originals. So what we'd like to do is have some way of passing in the originals so that the changes made by the function are reflected back in the calling function. And C++ makes that very easy. I can put an ampersand in front of each of these. And that says, don't work on copies, work on the originals. And then we'll rerun this thing with ampersands in place, and you'll see that we get the results that we want. So before we were getting junk. Why were we getting junk? Because we were essentially printing out uninitialized variables. We declared them, and then we printed them out. Now that we've allowed the getInputs function to work on the originals rather than copies, the originals come in, they get their values, and then when I get back out to the calling function, because we were working on the originals, when we print out those values, we get the values that we expect. And what's really nice about that is now these three values, having been modified by this function, go into this function to compute the gravitational force. This is called pass by reference. And it lets the function have access to the original variables, not copies. Changes made by the function Okay, we'll talk more about this after the exam. Next time we'll do a bit of review for as long as that takes, and then Friday, the exam. See you Wednesday. What's up, Paige?
Sure.
Yep.